Today, I am preparing to share a case study from book recommendations. This sharing is organized as follows. First, I'd like to emphasize the significance of data skills for students. Connections are everywhere and very much enhanced in the internet era. They are driving power of many things of daily life like recommendation. Data skills are fundamental and pivotal when it comes to career choice. In China, students in their first year of high school need to choose subjects which they will participate in college entrance examination, and like different subjects combines determine their choice of major when they are entering university. I believe that there are long-term benefits for students in acquiring these skills at an early stage by analyzing data. Students can grasp the underlying principles and gain a better understanding of data security. This in turn fosters an early awareness of analysis and allow them to start accumulating decision-making experience, which ultimately empowers them to make better choices for themselves. Why I choose the graph as a teaching tool? Because the graph is easy to understand and the graph database supports the project-based learning. With a focused recommendation system, students shift from passive knowledge recipients to active explorers through hands-on exploration and practice. They learn and grasp various data analysis concepts by actively participating in data collection and analysis using a pre-class online questionnaire for similarity data collection. Students gain real-life insights into data gathering, including basic information and individual book preference in the class. They analyze and collected data from a different perspective to understand its potential for analysis. Selecting Neo4j as a tool to teach book recommendation systems rely on its inherent intuitiveness. Neo4j visually represents data using colors and shapes, enable students to interact with data in an intuitive and straightforward way. This visualization transforms abstract relationships into concrete, engaging concepts, which is especially valuable when imparting fundamental knowledge. Modern recommendation systems are a popular topic in academic contexts. It's different educators employing various methods to explain and present this subject. In my view, this system primarily depends on extensive analysis of user behavior and big data to deliver personalized recommendations. Data is the cornerstone of a recommendation system. In our class, students can have the opportunity to witness how their data is collected and processed to create tailored suggestions. To introduce students to collaborative flirting algorithms, we identified peers with similar reading preferences as the target audience for the personalized recommendations. To address spurious data, we employ the jagged similarity as a calculation method with Neo4j. The graph data science library comes with the jagged similarity function to help rapidly determine the number of shared neighboring nodes and thereby assuming similarity score. We can also create a similarity relationship among classmates and visually nodes and relationships who share the common reading preference based on specific criteria. Next part is some course details. This lesson serves as an overview encouraging students to engage in independent exploration. This is achieved through activities like discovering follow reading enthusiasts and forming book clubs. Throughout this journey, the teacher facilitates collaborative learning with demonstration and lectures while offering valuable feedback. I've also prepared macro lessons, study materials, and additionally learning aids to enhance scenario-based activities for students. This lesson compares 6 sections, fostering parallel development of scenario and knowledge acquisition. I'd like to share this course section primarily centers around introducing concepts and building models. The instructor three essential components of graphs and graph database: nodes, relationships, properties based on prior graph required results. Following macro lessons and study materials, students log into the Neo4j platform to get acquainted with the fundamental operations and recognize how those three elements are represented on the platform. When students seek like-minded pairs, they learn the match statement in the Cypher. Once they identified classmates who share the same favorite books using the match statement, question arises. But does liking the same book equal to similar reading preference? The teacher promotes students to consider how to define similar reading preference, how to find classmates with similar reading preference. Keeping this question in mind, the course proceeds to the activity 2, forming a book club. In case 1, students learn that the more books they share, the more aligned their reading preference tend to be. In case 2, students recognize that merely counting shared book isn't a precious measure of reading preference dissimilarity. As a result, the teacher organizes students into the group to develop deeper into the study materials and encourage them to share their material to simply. I will skip this video. Okay, next. I'd like to discuss the challenges I encountered and how I overcome them. Initially, as a teacher, I need to acquire the necessary knowledge of database operation and Cypher syntax while ensuring that database could run our school device. I'm very grateful for Dr. Yu for providing substantial support throughout this process. However, this is several challenges during the installation, largely due to the internet and device compatibility issues. Although I attempted to use the Huawei cloud platform, it doesn't provide smooth access for the students. After several attempts, we managed to successfully install the software is a recently updated computer lab. While the exact reasons for the previous installation failure remained unclear, I persevered while I returned the installation after a few days of waiting. Another significant aspect of my work involved determining the specific content I wanted to teach for 10 grade students. Graph concepts in mathematics were relatively unfamiliar and they tended to view graph data as image. It was challenging to decide what graph concepts are essential for the class. I discussed this issue extensively with my colleagues in the teaching research group, only 5 minutes to introduce the basic of graphs. I utilized methods such as Blackboard illustrations, student interaction, and on-screen presentation to help students grasp concepts of nodes and edges as they gain knowledge about nodes, relationships, and properties in the database. Cypher syntax was entirely new to me and my coworker. We not only had to learn how to use it, and also had to determine how much of this syntax 10th grade students should grasp in initial class and how much they could explore independently during the activity. Ultimately, we chose to focus on the match statement and introduce basic syntax, providing temples, allowed students to modify nodes and relationships. We leverage the ability to work with the pre-existing code in the student machine, enabling them to conduct dependent inquiry for various purposes and levels. At last, I will display this course get some outcomes in our school in China. Maybe that's all. Thanks, everyone. I hope the time is right.